this is problem number 6. So, given two linked lists sorted in ascending order, merge them in place and return the head of the merged list. For example, if the first list is this, and the second list is this, then the result list should be them two merged. Now, something to note is that these lists are already they're given as sorted. So let me begin with the function definition. I'll be returning a node and name the function merge lists. This will accept a two linked lists, one named L1, one named L2. And the approach I'm going to take is to merge everything into L1, essentially. So that means that I need to guarantee that L1 is going to be the smaller of the two heads. Because remember, these lists are already sorted. So if L2 happens to be bigger than L1, then I will swap them. So I'm saving the head of L1, changing L1 to be L2, and replacing L2 with the stored L1. Now I will create several nodes. And I'll explain in a second what I'm going to use this for. Okay, so prev L1 and current L1 are going to span where we're going to insert current L2. So current L2 is running down on singly linked list L2, and current L1 is and prev are running on L1. I'll begin looping over things while current L1 is not null and current L2 is not null. Well, there's still elements in both of these lists. If we are on the first time through things, prev L1 will still be null. So we're identifying if we're still in the first run through. Then increment prev and current. So prev is current, current is current dot next, and so we come back around here. Okay. Why are you mad at me? Oh, because this is saved as a Python file. Just ignore. That might get a little ugly. Let's just roll with it. I'm just using it as a whiteboard. If, actually, no, let's move this. Alright. Okay, why? 1 second. Let me just. That didn't help. Okay, continuing on. If current L2 dot data. So right now, I'm checking if current L2 is going to fit between prev L1 and current L1. So it's going to fit between them if it's equal to the lower or upper range, so prev 1 or current 1, or if it's in the middle of those two. So if it's equal to it, I already checked. Now I'm going to check if it's between it. Okay, so if we do need to put current L2 between prev L1 and current L1, let's take care of that. First, nullify prev.next. And reassign the head value for L2 because current L2 will be moving on to the next element, which will become the head after we place current L2 within list 1. Okay, so I have inserted it into the list, nullified its next pointer, and then assigned its next pointer. So now current L2 exists between prev L1 and current L1. And then let's move these along. So increment everybody. Awesome. So done with that. If block else, if so, if current L2 did belong between prev L1 and current L1, then it gets put there. Else, if we're not at the end of current L1, then we just increment these guys without inserting anybody. And lastly, if we are at the end of current L1, then current L1.next is current L2. And outside of this while block, I'm going to return L1.head, and that is my solution. Okay, so a brief discussion of time complexity. Time complexity is going to be big O of m plus n, where m is the number of nodes in L1 and n is the number of nodes in L2. Space complexity is constant. We're just moving the nodes pointers around, essentially, so not using any extra space there. Okay, let's think of an example that we can run through. I want to pick something a little bit shorter than this. So let's just take this one, but we'll chop a little bit off. Okay, so got L1, L1 and L2. And let's say that, yeah, this will show up well. Okay, so L1 is 1020 null, L2 is 15 null. All right, so if L2.head.data, moving right in, is less than L1.head.data, no it's not, we don't have to switch these guys right now. Prev is null. Values, L1. The current L1 is L1.head is 10, and current L2 is 15. Okay, wow, current L1 is not null, current L2 is not null. Amazing. If prev L1 is null, yes it is. Prev is now current L1, so alright, prev is now 10. Current L1 is current L1.next is 20. Awesome. And continue. Great, so we go all the way back around. Enter here again, none of them are null. Okay, these are not true because 15 does not equal 10 or 20, but this bottom statement is true because current L2 15 is in between the values of 10 and 20. So we're going to carry along with this section here. Prev L1.next is null. Alright, so this pointer goes away. Or is assigned a value null, so I'm going to denote it as going away. L2.head is assigned to current L2. Well, this is already the head, but okay, moving on. Prev L1.next is current L2 is assigned to be prev L1.next. So I've drawn a line, a pointer from 10 to 15. There, okay. Moving on. We just did that. Now, current L2.next is null. Alright, current L2.next is null. Well, this is already null, so that's fine. We can show that over here as well. Current L2.next is null. Current L2.next is current L1. So now we have this connection. Let's see how it exits out of here. Prev L1 is prev L1.next. So prev L1 now becomes 15. Current L1 is prev L1.next. So now prev L1 is 15, so .next is 20. That was already assigned that, coincidentally. Current L2 is L2.head. Okay, that's fine. If current L1.next is not equal no. If current .1.next is null, need another equal sign there. Then current L1.next is, well, that doesn't work. I think I need to add, I think I need to add something here. Current L2 is L2.head. Let's see. I think I need to check, maybe not up there. How about if I check if I must not have run through this test case when I was testing. That's fun. If current, okay, how about this? L1.next is null and current L2.next is null. Then I'm going to, because current L2 is that's not what I want to check. I want to check current L2 is L2.head. No, L2.head. Why? L2.head is assigned to. Oh, we're moving along. Okay, so we're just moving along. So did I reassign? L2.head is current L2, which would have been 15. I think this, yeah, this just needs to be .next. There. And then this is true. L2.head is current L2.next. Right, and then if L2.head.next is null, then okay. Thanks for staying with me and implementing that bug fix. This is my solution.